Okay, we're in section 4, chapter 6, and I think we'll do the first bunch of numbers, first couple like 15 or something like that. These are just questions of whether they're rational or irrational. So we have 4 divided by 9, which is rational because it's a ratio of 2 integers. 2 is 7 divided by 8, which is also rational because it's also the ratio of 2 integers. 3 is the square root of 10 because it's not a perfect square, it's irrational. Okay, number 4, square root of 14. Again, it's not a perfect square, so it's irrational. Number 5 is 1.618. Well, it's got a finite number of decimal places, so it's rational. 6 is 2.718, which is kind of an approximation for E, but this only has, again, a fixed number of decimal points, so it's rational. 7 is 0.41 with the repetition, so this is okay. If you keep, this means it's 0.41414141. And as long as it's repeating, it is rational. Number 8 is 0.32, same reason, it's rational. 9 is pi, which is irrational. That's one of our big 3 irrational numbers, pi, phi, and E. 10 is E, okay, so that's also irrational. And 11 is 3.14159, which is rational. It's an approximation for pi, but it's because it stops here, it's got a fixed number of decimal points. And 12 is also an approximation for pi, which is 22/7, but because it's a ratio of 2 integers, it's a rational number. Okay, next one, 13. It's 0. Sorry about that. Something just popped up, which I need to unpop. So it goes 8, 7, 8, 7, 7, 8, 7, 7, 7, 8. And so you might think this is rational because it has this 8, 7, 8, 7, 7, 8, 7, 7, 7. It's kind of it's predictable, but it's not repeating. You know, it doesn't go 8, 7, 8, 7, 8, 7, 8, 7. That would be rational, but 8, 7 this, so this is irrational. And 14, which is the definition of phi, because it includes a square root as a consequence of that, it's irrational. Okay, so that's the first bunch. Let's look at problem 17. Use a calculator to find a rational decimal approximation for each irrational number. Give as many places as your calculator shows. So we have the square root of 39, which according to my calculator is 6.244997998. Okay, but it actually has an infinite number of decimal points. 20, the square root of 33.6. Square root of 33.6 is 5.796550,698. 23. Okay, square root of 9/8. So there's 2 ways of doing it. You can take 9/8, 9 divided by 8, and then you take the square root of that, which is square root of 1.125. So that would be one way. It's just the same as the square root of 1.125, and you get 1.060660172. Okay, so that's irrational. You could also be the, it's the square root of 9 divided by the square root of 8, which is equal to 3 divided by the square root of 8. You do that. It's also equivalent to 3 divided by 2 times the square root of 2, because there's a perfect square in here. How did I get that? So let me go back up here. So the square root of 8 is the square root of 4 times 2, because 2 times 4 is 8, and the square root of 4 is 2. So you can rewrite that as that as well. So so you can take 3 divided by 2 divided by the square root of 2, which is the same number, of course. You could also, what else could we do? There's something else we can do here. Oh, you can, if you have your calculator has an exponential function, you could say 9 divided by 8 to the 1/2 power, or to the 0.5 power. That's, so if you put a parenthesis, 9 divided by 8, close parenthesis, and then use your little hat thing and put 0.5, you get the same number. So sometimes it's easier to do that than to do the square root, especially if you do this calculation and you get a number. To get it to do the square root, you've got to write the number back down again. But in this case, you just go hat 0.5 and you get the answer. So, this, if you were to do your calculator, you probably 9 divided by 8 will give you 1.125, and then you'd raise it to the 0.5 power, and you get the same answer. So there's a couple of ways to get square roots. Okay. Use methods of example 1 to simplify each expression. Then use a calculator to approximate both the given expression and the simplified expression. So it's what we just did here. Oh, I gotta pause a second. My airliner's about to crash, so hold on. Okay, I'm back powered up again here. So 25. So we have the square root of 50. And the question is, can I rewrite 50 as a perfect square and another number? Well, the answer is yes. Perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, etc. So 2, 3, 4, 5, 6, 7, 8, 9 squared. So 50 can be rewritten as 25 times 2. So that's the same as the square root of 25 times the square root of 2. But the square root of 25 is 5, so you can simplify that down to 5 times the square root of 2. And if you plug in both of them, you'll get 7.07106, etc. Okay, let's look at 28. So we have the square root of 150. What's that equal to? Well, it's equal to 25 times 6. So it's the square root of 25 times the square root of 6. And you can't make 6 out of a perfect square because the only number that's less than 6 is 4, so that doesn't work. So you get 5 times the square root of 6 in that case. And if you multiply it out with a calculator, you'll get the same answer. That number. Okay, 31. 5 divided by the square root of 6. Okay, so let's do another one. This is something people, I think, have issues with, so we're going to do 20, we did 25, 28. Let's do 29. So we have the square root of 288. So the question is, can you divide that by 4? Try this first one. So 288 divided by 4 is 72. Okay. So that works. Try 16 because that's the next one, the next even number up. So 288 divided by 16 is 18. Okay. How about 36? 288 divided by 36 is 8. And how about 64? 288 divided by 64 is 4.5, so that doesn't work. So let's write this. Okay, hold on just a second. I've got to plug this thing up. Apparently, it doesn't like me. I have it plugged up. Okay, now we're good. So we can say this is the square root of 64 times. If you divide 288, well, no, the square root of 64, you get the square root of 36. So take 288 divided by 36, and you get 8. So so that's square root of 36 is 6, so we have 6 times the square root of 8. But you can see that we can rewrite the square root of 8 as 4 times 2. So that's the same as 6 times the square root of 4 times the square root of 2. And the square root of 2 is 2, so you get 6 times 2 times the square root of 2. And the final answer is 12 times the square root of 2. And that number is 16.97056.275. Whether you do this or whether you do that, you'll get the same number. Okay, now let's look at the 31. This is a case of where you have to, this is not in the simplified form because you have a square root in the denominator. So the way you get rid of that is you multiply by the square root of 6 in the numerator, divide by the square root of 6 in the denominator. This is 1, it's equivalent to 1. So when you multiply the square root of 6 times the square root of 6, you get 6. And then the numerator becomes 5 times the square root of 6, 5 times the square root of 6. And that number is 2.04124145.2, no matter which way you do it. Okay, so let's look at the square root of 8 divided by 9. Well, that's the same as the square root of 8 divided by the square root of 9. And the square root of 8 is going to be the square root of 4 times 2, and the square root of 9 is just 3. And since we have a complete square, one of these complete squares, we can rewrite, well, what we do is rewrite that as the square root of 4 times the square root of 2 over 3. But that becomes 2, so you get 2 times the square root of 2 over 3 as your final answer, which is 0.9428090.416. Okay, I'm going to stop there and we'll continue on in just a second.